Every dishwasher in the world does basically the same thing. It heats water to nearly 70 degrees Celsius and relies on heat and pressure to blast grease off your plates. That's true across every brand, every model, every country. The formula has never really changed. But in China, engineers filed a patent for a completely different kind of cleaning machine. It doesn't rely on boiling water. It uses sound. A sound so high-pitched the human ear can't even detect it, but strong enough to strip away stuck-on grime without needing heat. This invention already exists, officially documented, with a registration number and a public technical description. And if the same physics behind it ever reaches your kitchen, the dishwasher you know could be on borrowed time. Here's how it works and why it isn't in your home yet. Dishwashers sit in a massive share of households around the world, and even people who wash by hand spend, on average, several minutes a day standing at the sink, every day with no break, year after year. Multiply that across a lifetime, and it's a staggering amount of time, hot water, and electricity that most of us never stop to add up. The model behind it has barely changed since the modern home dishwasher became common. Heat the water, add detergent, build pressure with rotating jets, and repeat for a full cycle that can run 1 to 2 hours depending on the setting. That consumes, on average, somewhere between 10 and 15 liters of water per cycle in conventional machines, and a large share of the energy spent in that process doesn't go to the motor or the jets. It goes to the water heater, which has to raise the temperature again and again, cycle after cycle, year after year. It's a system that solves the problem, but with a lot of built-in waste. Energy burned just to heat liquid, not necessarily to clean more effectively. And that waste is exactly what Chinese engineers set out to attack. Here's something most people never stop to think about. Heating water is, by far, the most expensive part, in terms of energy, of the entire wash cycle. It's not the motor spinning the jets. It's not the detergent compartment or the electronic panel. It's literally heating water to a temperature high enough to melt grease and kill bacteria every single time the machine runs. And even with all that energy spent, the method is still fairly blunt. High-pressure water jets, spinning mechanically, statistically hoping to hit every inch of every plate from every angle. Corners, the folds of cutlery, the bottom of tall glasses, the underside of stacked bowls. These are classic blind spots, where grime survives even after a full cycle because the water jet simply couldn't reach with enough force. That means two overlapping forms of waste, stacked on top of each other. Energy spent heating water that doesn't always clean everything, and cycles that sometimes have to be repeated, which doubles the water, energy, and time the machine already burned on the first attempt. Manufacturers tried to tackle this problem from several angles, over years of small improvements. More powerful jets to try to cover more surface area. Redesigned rotating nozzles to change the water's spray pattern. Sensors that measure water turbidity mid-cycle and automatically adjust wash duration. Some models even added steam pre-washes, trying to soften grime before the main cycle. All of these solutions, however, remain tied to the same basic principle: hot water plus mechanical pressure. They optimized the old formula, made it a little more efficient here and there, but never changed the formula itself. And by design, that means water and thermal energy consumption never drop below a certain floor, no matter how many new sensors or nozzles get added. What if, instead of relying on heat to soften grime and water pressure to blast it away, sound could be used to do most of the heavy lifting? That question is what led an engineering team in China to file a patent, officially identified as CN10623591A, for a dishwasher that combines an ultrasonic emitter with high-pressure injected air. Instead of depending almost entirely on hot water, the machine described in that document uses high-frequency sound waves to carry out much of the cleaning work that, until now, was left entirely to heat and jet force. Here's the simple version of how this Chinese invention works. Picture throwing a stone into water. It creates a ripple that spreads out in circles. Now imagine doing that thousands of times per second, at a frequency so high the sound becomes practically invisible to our ears. That's the principle behind ultrasound. Vibrations above the limit the human ear can detect, generally above 20,000 cycles per second. According to the patent, the machine combines that high-frequency sound with high-pressure air injected into the wash water. That combination creates tiny vacuum bubbles, practically invisible to the naked eye, scattered throughout the liquid. A fraction of a second after forming, those bubbles collapse in on themselves, a phenomenon with a technical name, cavitation, releasing a small burst of energy in the form of an extremely concentrated microjet aimed exactly at the spot where the bubble burst. Individually, each of these implosions is tiny, almost insignificant, but multiplied by millions every second, spread throughout all the water in the machine, they act like an invisible army of microscopic scrub brushes, working simultaneously across every inch of the surface, including corners, crevices, and curves a regular water jet normally wouldn't reach as effectively, no matter how strong it was. The practical result, described in the patent document itself, greater cleaning impact force, achieved through the mechanical energy of these micro-explosions, not through the temperature of the water. It's a completely different way of attacking the same problem: grease and food residue stuck to dishes. And this is where the story gets more interesting, because this isn't an isolated idea dreamed up out of nowhere by a single inventor working alone. It's part of a much broader trend that has already existed outside the kitchen for quite some time. Ultrasonic cleaning has been used commercially for decades in entirely different fields. Hospitals use it to sterilize surgical instruments, reaching corners and crevices a manual brush would never get to. Auto repair shops use it to clean engine parts covered in hardened grease without having to manually disassemble every component. Jewelers use it to remove grime embedded in tiny details on rings and chains, where any cloth or brush would be too crude. In every one of these cases, the principle is exactly the same: high-frequency sound generating cavitation inside a liquid. The Chinese dishwasher patent takes that same physics, already proven and tested across other industries for years, and applies it specifically to dishes, both household and commercial, according to the document's description. Here's the important detail, and this is where the story turns honest rather than just exciting. The patent's own text acknowledges that the structure, as described, works better in large-scale machines built to wash many items at once, and not necessarily in a small, compact dishwasher for an ordinary apartment kitchen. Shrinking that physics down to fit inside a household appliance, using little energy, without making it too expensive to manufacture, and keeping the same cleaning effectiveness, that's the engineering challenge still being worked out. It's not a small detail. It's the very obstacle standing between registered invention and product on the shelf. In other words, the invention exists, it's Chinese, and it's officially documented, with solid physics already proven in other applications. The question left isn't whether the underlying principle works. That's already been settled for decades in other industries. The question is whether it can shrink, moving from an industrial kitchen setup down to your kitchen counter.
Before we continue, if this Chinese technology arrived ready for your kitchen tomorrow, no hot water, just sound, would you swap out your current dishwasher, or would you wait for someone else to test it first? Let us know in the comments. And if you enjoy following Chinese inventions that could change everyday objects we use without a second thought, consider subscribing to the channel. There are more stories like this coming. Now, the part many videos like this skip on purpose to seem more exciting. This invention still has real, concrete barriers before it becomes a common kitchen item. The first is scale and cost. The patent document itself describes a structure built for large-scale use, with components that make economic sense when you're washing hundreds of items a day in a restaurant or hospital. Not necessarily when you're picturing a compact, quiet appliance cheap enough to sell in mass volume for ordinary residential kitchens. The second is the question of thermal disinfection. In many countries, there's an expectation, and in commercial settings, sometimes even a regulatory requirement, that water reach a minimum temperature to reliably disinfect dishes, especially in restaurants and hospitals. That means even if ultrasound cleans visible grime very well, some settings may still require some supplemental heat source. Maybe far less than today, but probably not zero. The third is real-world household validation, day-to-day.
So far, there's no widely published, independently conducted study comparing a household version of this technology side by side with a conventional dishwasher under real kitchen conditions with actual food grease, rather than only in a controlled lab environment or industrial application. So this isn't a story about the dishwasher you know is already obsolete today, right now, at this exact moment. It's the story of a real Chinese invention, officially documented, with physics already proven at a different scale, one that's still trying to find its way to your sink. There's something interesting about watching China file patent after patent, rethinking household appliances the rest of the world stopped questioning decades ago. Things so common, so present in daily life, that most people never stopped to imagine they could work any other way. The physics of ultrasound already cleans surgical scalpels, watch gears, and engagement rings in ways that are proven and reliable. The question left isn't, does this physics work? That's already settled, tested, documented. The question is, when will engineering catch up to the physics and bring this invention in an accessible, compact form into an ordinary kitchen? If that happens, the dishwasher might just be the beginning of a bigger shift. How many other appliances you use every day, without even thinking twice, still rely on more heat, more pressure as the default answer to dirt, while a quiet invention on the other side of the world is already trying to prove there's a completely different way to solve the same problem? What do you think? Would you trust a Chinese dishwasher built on sound, even knowing the technology is still maturing and far from ready for everyone? Leave your answer in the comments, hit like if this invention made you think differently about an everyday object, and subscribe to catch the next invention that could be about to change your kitchen.